At first, it was just another comet. But when 3I Atlas entered our solar system, everything changed. Its speed, its path, and its chemistry didn't match anything we'd seen before. Then, Elon Musk launched a secret mission. No live stream, no press. What they found? That's when the fear really started. Discovery, when the sky spoke a new name. On July the 1st, 2025, at an observatory in Chile, the Atlas Survey Telescope picked up a faint light crossing the sky. At first it looked like a distant comet, but orbital data told a very different story. It was moving far too fast and on a path that no object from our solar system should take. Within 48 hours, astronomers confirmed the impossible. The object was following a hyperbolic trajectory, a flight path that only interstellar visitors follow. They gave it a name, 3I Atlas, marking it as the third interstellar object ever observed by humanity. The speed was over 130,000 km. The angle was steep, retrograde, and totally unnatural compared to normal comets. Its behavior was already breaking expectations. Unlike Oumuamua or 2I Borisov, this one showed signs of activity almost immediately, a coma forming and then a tail. But that wasn't the shocking part. The object's brightness and structure didn't quite match what a comet should look like. Some astronomers quietly began to say, something feels off. Inside NASA and the European Space Agency, the mood shifted from curiosity to cautious excitement. But behind closed doors, SpaceX engineers were already looking at something else entirely. If this was an object from another star system, then it wasn't just a passing visitor. It was a chance, a once-in-a-generation opportunity. As one scientist put it, this isn't just a rock. It's a time capsule from another world. And time was short because 3I Atlas wasn't slowing down. It was heading toward the sun, and fast. Why was this one different from the start? From the moment it was confirmed interstellar, 3I Atlas refused to behave like anything we'd seen before. First, its speed, more than 130,000 mph. That's not just fast. It's leave the solar system and never return fast. Second, its orbit was retrograde. It moved against the usual spin of planets and comets in our system. That made observation difficult and any idea of interception even harder. Then came the chemical surprises. Data from the James Webb Space Telescope revealed a coma dominated by carbon dioxide, with a CO2 to H2O ratio of 8.1, a ratio never before recorded in any known comet. Polarimetric studies from ESA's observatories added another twist. The object showed a deep negative polarization branch, an optical feature not seen in normal solar system comets. In simple terms, it reflected light in a way that hinted at exotic materials. And that's not all. The object's glow appeared to pulse slightly, not due to sunlight, but from something intrinsic. Some researchers called it a self-glow. A few fringe voices even wondered, was it natural at all? Could it be artificial? Most agencies remained cautious. But inside SpaceX and among independent astronomers, the question was becoming unavoidable. If it's natural, it's the weirdest comet ever. If it's not, then what is it? Elon Musk's response. By mid-July 2025, an internal report landed on Musk's desk. At first glance, it looked like another unusual comet update. But the subject line caught his eye. 3I Atlas, interstellar. Retrograde, CO2-rich. He read the rest twice and then, according to insiders at Hawthorne, everything changed. SpaceX's orbital analytics team had flagged the object not because it was a threat to Earth, but because of what it might be. A high-speed interstellar object was rare enough, but this one was active, glowing, pulsing, emitting gases at a chemical ratio not seen in any solar system object. The phrase that reportedly stuck with Musk was this: "This is not a native body. This is a cosmic messenger." Elon had long seen himself as a guardian of humanity's future, and an opportunity like this couldn't be ignored. Here was a once-in-a-civilization chance to intercept an object from another star system, something formed long before Earth existed, carrying unchanged matter from the dawn of time. It wasn't just about science. It was about being first. He called an emergency meeting with senior engineers and flight planners. One insider said Musk asked a single question that cut through the noise. Why are we letting this fly by without doing anything? The room went silent. Within days, SpaceX initiated feasibility studies for a rapid response mission. It wouldn't be a flagship billion-dollar probe. There was no time for that. But a small, agile microprobe strapped to a Falcon 9 might just make it. The target, the coma or tail of 3I Atlas. Not to land or collide, just to fly through the dust, scan it, maybe even sample it. Still, the risks were huge. If the intercept failed, SpaceX would face public humiliation and billions in scrutiny. If it succeeded, it would be the first human-made object to ever touch material from beyond our star. Behind the boldness, though, there was something else. Fear. Musk, known for dismissing danger, seemed unusually measured in private. Colleagues said he wasn't scared of a collision. He was scared of not knowing, of letting the unknown pass us by, of being the species that watched the future approach and blinked. The mission wouldn't be announced. There'd be no live stream, no countdown clock. This was off the books and fast. The timeline was brutal. If they missed the intercept window, which would close by late August 2025, the object would swing past the sun and accelerate out of reach forever. One Falcon engineer said later, "He told us, if we hit this, we hit history." But first, they had to solve the impossible math. The mission. The next 10 days inside SpaceX were pure chaos. Engineers, orbital analysts, and propulsion experts worked around the clock, and the more they looked at it, the worse the math got. 3I Atlas was flying at over 130,000 km/h, far faster than any mission humanity had ever tried to intercept. Unlike past missions like New Horizons or Parker Solar Probe, which took years and multiple gravity assists, this plan had no luxury of time. They had 6 weeks, maximum first problem, propulsion. Falcon 9 was reliable, but not designed to chase interstellar bullets. A traditional payload would never reach the target. So they began stripping things down, shaving weight, simplifying systems. The only hope was a micro-payload launched quickly and precisely, maybe even a swarm of sensors. Redundant probes would increase the odds that one might hit its mark. Second issue, trajectory. They weren't trying to chase the comet directly. That would be suicide. Instead, they aimed to intercept a patch of space, a precise location the comet's tail would sweep through. As one mission planner described it, it's like firing a dart into a hurricane and hoping it catches the wind. Third, timing. Even a 1-second error could mean a complete miss. The intercept had to be calculated down to fractional seconds, accounting for solar wind, comet outgassing, and orbital drift. SpaceX simulations ran non-stop, adjusting launch windows by the minute. One miscalculation, and the probe would fly into empty space. Then came the technical gambles. Rumors swirled of experimental technology, laser propulsion, beam steering, ultra-high-speed communications. Some of these systems had been shelved for years. Others had never been tested in space, but Musk gave the go-ahead to try them. The reason? There wouldn't be a second shot. Internally, the team was divided. Some said the mission was too rushed, too reckless. Others believed it was worth the risk. One aerospace lead summed it up perfectly. This might be our Voyager moment. But instead of sending a message out, we're reaching to pull one back. By early August 2025, a flight plan was approved. A secret Falcon 9 launch was scheduled. No press, no broadcast, just a cold calculation and a fast, quiet countdown to a window that would never open again. And the world would only know the result if something happened. The launch. By mid-August 2025, something unusual appeared on tracking radars. A Falcon 9 launch registered with no declared payload, no press coverage, and no live stream. For a company known for its public launches and flashy countdowns, this silence was deafening. SpaceX's official manifest had a sudden blank. No satellite customer, no Starlink mission, just a classified trajectory and a departure time logged in the early morning hours. When amateur satellite trackers looked closer, the path raised eyebrows. This rocket wasn't headed for low Earth orbit. It was arcing into deep space. Whispers began circulating online. Was this the 3I Atlas mission? Had Elon Musk quietly greenlit the intercept? No official confirmation came, but inside the aerospace community, leaks trickled out. The payload was small, light, and fast. It may have been a swarm of microprobes, each no larger than a suitcase, designed for high-speed navigation. Or maybe, as some suspected, it was a single specialized probe packed with experimental tech, directed energy thrusters, high-speed spectrographs, or even a sample collector built to survive the chaos of a comet's tail. The goal wasn't to crash or land. It was to graze the comet's coma, the hazy cloud of gas and dust surrounding it, and capture whatever could be collected: particles, molecules, spectrographic readings. Even a few grams of alien dust could change what we know about stellar chemistry, life's building blocks, and our place in the universe.